Hello everyone, my name is Joshua Shewmaker and I did the state design pattern, which is a behavioral design pattern that works with classes and objects so you can keep the same object but constantly change the state that it is in. So the intent of this design pattern is to allow an object to alter its behavior when its internal state changes. The object will appear to change its class, but in actuality it's the same class throughout the whole life span of the object. So what problems does this solve? Typically when you have a class with a bunch of different states, you're going to have a bunch of different functions for each state within the class. This makes it difficult to add new states because anytime you would add a new state, you would have to go into each function and add on to the if else statement to check which state we're in, which state we're going to. And it makes the code really messy and leaves a lot of room for errors because you could forget to go into a specific state and add the new state onto an old state and things like that. So what this does is it splits the states into their own classes using an interface. So this is the base structure for the state design pattern. So you have your client, which is just your main, which is where all the code will be running. Here's your context class. So this would be your actual thing that is changing state. So it could be a car, a robot, a vending machine, some kind of object in a video game. Then we have our state interface, and this just holds the methods that all the states can be in. And each of the states implement that interface. So as you can see in the base, we just have 3 states here. You can have as many or as few states as needed. And they all implement that state class, which the context class would then call upon. So for my example, here's the implementation of the state design pattern that I have. I did a vending machine. So as you can see, my vending machine can take money, it can refund money. You can select an item and then it will dispense the item. And my state interface also implements all those same functions. And as you can see down here, here are my 4 states that the vending machine can be in. So, as you can see, we have the sold state, the sold out state, the no money state. So if we're just waiting for money, and the has money. So I've been have money inserted in me and I'm ready to make a selection. So if we go to that code real quick. So here's my context class, which is the vending machine class. So it declares all the states, as you can see, and then in the destructor we initiate them. And then as we need them, we can call them through the vending machine object. So let's say we are in the no money state. So the vending machine doesn't have any money in it yet, and it's waiting for an action. So we have our vending machine object in the constructor. If we insert money into it, we are changing from the no money state to the has money state. So here you can see we're alerting the user that money has been inserted, and we are changing the state of the vending machine to say we have money. And so that changes some of the things that the vending machine can do. We can no longer accept money. As you can see here, since we already have money, we can't accept any more. We can eject the money, so refund the money if the user wants just to get their money back and doesn't make a selection. Or they can now select an item, which would then change the state of the vending machine into the sold state. So if we look at the interface, it's just a very quick interface with all of our functionality in it. Nothing declared because the actual state of the classes will declare each of those. So now if we go into and actually run this program, let's see right here, we just have a simple user interface through the console that lets you insert money and select items, and so those are the only 2 states the user can interact with. The other 2 states are states that the machine handles on its own. So if we run this real quick, we'll get a pop-up down here. Vending machine has 10 items in it, and it lets us know the state it's in, as it's the has no money state. So we're currently accepting money. So I can insert money or select an item. So let's say I didn't insert any money, and I go to select an item. So I hit 2, and it'll say it knows it's in the money of accepting money. It's not in the state that it has money. So it's letting me know it can't dispense an item. I need money first. So if I insert money, you'll see money inserted. The state will change. And then if I select an item, we now get this readout of item selected. So, and that just happens. So if we go to the no money state once again and look where we select an item, you can see it printed this out. Please insert money before selecting item, just like we had down here. And the has money state, or the back to the no money state, once we inserted the money, it says money inserted, which is down here, changes the state to has money and lets us select the item. It says item selected. Then we go to the sold state, which then dispenses the item. So as I said before, this is helpful when you're dealing with objects that have different states. So if you're in a car and you want to drive somewhere, the first thing you have to do is start the car. Then you can go forward or go in reverse, put the car in park, and then turn it off. All those states have to happen in a specific order. And instead of having a bunch of functions that become messy to deal with and work in and add to, you can create them in separate classes that just worry about themselves. So if I'm in the off state and I want to drive forward, the car just worries about being off or being on. Where once I'm in the forward state, the forward would just worry about continuing moving forward or stopping, and it doesn't have to worry about the rest of what the car can do. So the times you would use this is when you have a complex set of possible states, as I said, that apply to the object. So easy way to determine if you want to use this design pattern is when you're doing state diagrams. And if you notice you have a bunch of circles, which are the states, and a bunch of arrows, which would be the transitions or the actions going from one state to another, you might want to consider using this design pattern. It's a very simple way to see that this would be helpful to you. And as I said, you can update the state at any time with special logic if the object is merely a state-owned property. So it helps objects representing real-world concepts with compound workflows and state. It makes this a great option for that. And that is my presentation. Thank you.